Okay. For problem number 1, we need to classify quadrilateral PQRS. Whenever we go to classify a quadrilateral, we need to start by asking ourselves which of these 3 types of quadrilateral it is: parallelogram, trapezoid, or kite. Let's start with parallelogram. If it's a parallelogram, the opposite sides should be parallel. So looking at this, are the opposite sides parallel? Skip a side, and you should be looking at opposite sides since they are in order. So these are the slopes of opposite sides. Are these parallel? No, these are not parallel. If they were parallel, they would have the same slope, not reciprocal slopes. So this is definitely not a parallelogram. So we can eliminate all of those options. It's not a parallelogram, so therefore it's not a rectangle, rhombus, or a square. So that leaves us with either trapezoid or kite. Let's go to trapezoid next. Okay, is it a trapezoid? Well, the definition of a trapezoid is it will have exactly one pair of parallel sides. Okay, so looking through these slopes, are any of these the slopes of parallel lines? Are any of these sides parallel? No. All of these are different. Not a single one of these slopes is the same. That means this cannot be a trapezoid. There are no parallel sides. Okay, so it is not a trapezoid. Okay, so we can throw out trapezoid. That means unless it's going to be none of the above, the only thing left is kite. Okay, so this has to be a kite because for now I'm telling you that it's always going to be one of them. Okay, kite. But let's go ahead and follow through, and for the explanation we have to say why it's a kite. Remember, the definition of a kite is that we're going to have 2 pairs of consecutive sides that are congruent. Okay, so do we have that? These are consecutive sides. See how they're right next to each other? And they are congruent. Please understand the way this wraps around. PS wraps around, and PQ is the consecutive side. Okay, so these would also be consecutive sides. So we do have 2 pairs of consecutive sides that are congruent. So it is a kite, and we can say, okay, so we could say that it is a kite because it has 2 pairs of congruent consecutive sides, but opposite sides are not congruent. Or right here in parentheses I could have said, but not all 4 sides are congruent. Okay, so that's number 1. Number 2, is quadrilateral DRKM, if DRKM is a rectangle, which statement is not always true? Well, let's get a picture going. Alright, remember, we're looking for a statement that is not always true. They say, okay, if the slope of dr is 1/2, okay, so say if this slope is 1/2, then the slope of kr is -2. So here's kr, and that slope would be -2. Is that always true? Well, yes. If this is a rectangle, then these sides are perpendicular, and the slopes will be opposite and reciprocal. So if this one is 1/2, this one will be -2. That's opposite and reciprocal. So A is not the answer. Okay. If the slope of dk is 3, okay, dk is a diagonal. So let's see, if the slope of that was 3, then the slope of Rm is -1/3. Okay, then the slope of Rm, which would be like this, is -1/3. Whoops. Alright, the question is this always true? Well, these are the diagonals. So obviously these slopes are opposite and reciprocals. That would mean that these diagonals are perpendicular. So the question is, if we're dealing with a rectangle, is that one of the special properties? Will the diagonals always be perpendicular in a rectangle? And the answer is no. In general, the only special property of a rectangle is that the diagonals are congruent. If we had said that the diagonals were congruent, this would be always true. There are two shapes that have congruent diagonals, rhombus and a kite. And of course, also a square, because a square is a rhombus. But a rhombus and a kite have perpendicular diagonals. This would be true if it were a rhombus or a kite. But for a rectangle, is not always true. That means that B is the answer. We were looking for a statement that is not always true. Okay, so B was the answer. Now let's go ahead and follow through and look at the other choices real quick. The slope of dr is 1/2. Okay, if the slope of dr is 1/2, so here's dr with a slope of 1/2, then the slope of km is 1/2. Well, km is this side over here. Alright, and of course these are opposite sides, and in a rectangle these opposite sides will be parallel because it's a parallelogram. And so yeah, that's always true. If one of them is 1/2, the other one will be 1/2 because they're parallel. So that's why that one was not, that one is not the answer, because it is always true. And just glancing at the last one, if dk is 10, then Rm is 10. Okay, if dk is 10, okay, then Rm is 10. Well, yeah, that is the one special property of a rectangle. The diagonals are always congruent, and these are the diagonals, so they will always be congruent. So that's why D was not the answer. Okay, so that's how you do number 2. Alright, let's look at number 3. Okay, STAR is an isosceles trapezoid. We need to find the area. Well, the area of a trapezoid is 1/2 base 1 plus base 2 times the height. That should sort of remind you of the area of a triangle, 1/2 base times height. But instead of base, it's base 1 plus base 2. Anyway, so looking at this picture, the two bases are the 26 and the 12. Those are my two bases. So 1/2 26 plus 12, and of course the height is 24. Okay, if you put that in your calculator, that should give you the area. Alright, that's 456 square units. So yeah, that would be the area. Now let's find the perimeter. Alright, to find the perimeter, we need to know what these legs are. To do that, we can do the Pythagorean theorem, but it's going to take one extra tiny bit of thought. Because to do the Pythagorean theorem, we need to know what the other leg is of this right triangle over here. So the easiest thing to do is let's form both right triangles by doing this. Okay, so we have a right triangle over here too. If this is 12, right here in the middle, okay, so this is 12. Look, if the whole length is 26, what's 26 minus 12? 26 minus 12 is 14. Okay, so that means if I take this 12 away from 26, there's 14 left over. That means this piece over here would be 7, and this piece over here would also be 7. Alright, this is isosceles, so it should have the symmetry. Okay, so 7 plus 7 plus 12, I think you'll find that that adds up to 26. So now that I know that this is 7, I can do the Pythagorean theorem to find the other side. I'm going to call it x for right now. So if I do my Pythagorean theorem, just using this triangle right here, okay, the Pythagorean theorem becomes, you know, a squared plus b squared equals c squared. Okay, so that's going to be so that's 7 squared plus 24 squared is 625. So that's 625 is equal to x squared. Take the square root of both sides. And you're going to get x equals 25. Okay, so that means this remaining side, you know, it's isosceles, so both of these legs should be the same. This remaining side is going to be 25. Okay, now I have all of the sides, so the perimeter should be 26 plus 12, those are the two bases, plus 25 plus 25, those are the two legs. So add up those four, and that should give me the perimeter. So the perimeter is 88. Okay. Now for number 4, we're supposed to find the area of BYOC. So it's good to remember that the area of a parallelogram is just base times height. So again, it's similar to a triangle area, but without the 1/2 part. In this case, the base is 36 and the height is 24. So the area is simply going to be 36 times 24. So that's 864. Alright, that's how you do that. Number 5. BHNM is a rhombus. Okay. I think it will be helpful to draw a picture of this. So here is a rhombus. Okay, so here's B, H, N, M. Okay, so B, H, N, M. So let's see, BH is 8. So that means this is 8. NM is 8. Well, I could have told you that anyway. This is a rhombus. So all 4 of these sides should be the same. So really all of these are going to be 8, and I already know that. But also BN is 6. Okay. So BN is one of the diagonals, and that is 6. And HM is 10. Okay, HM is another diagonal. Okay. And that length is 10. Okay. Now, there are 2 ways to find the area of a rhombus. If I know the base and the height, which would be, like the altitude of the rhombus, then I can, a rhombus is a parallelogram. So I could use the same formula that I used for number 4. Area is base times height. But in this case, we're not given the height of this rhombus. The height is not the diagonal. The height would be if I turned this sideways and dropped an altitude directly to the ground. But there's another formula for the area of a rhombus that we can use. And that formula is the area is 1/2 diagonal times diagonal. Okay, again, it's similar to 1/2 base times height, but instead of base times height, it's diagonal times diagonal. So that's going to be 1/2 10 times 6. Okay, half of 10 is 5 times 6 is 30. So that should be the area of this rhombus. Of course, the perimeter is just the sum of all the sides, so that's just 4 times 8. Okay, 4 times 8 is 32. So the perimeter is 32. Okay, looking at number 6. The square is a special kind of rhombus and a special kind of rectangle. Okay, so we've got the square, we're given some sides. Maybe we should draw a picture. Here's the square. Okay, SQRE. So let's see, we have S, Q, R, and E. And what do we got? SQ is 18. Of course, QR is 18. We really didn't need to be told that. RE is 18. It's a square, so of course all 4 sides are the same length. Alright, but we are also given that QE is 18 radical 2. Okay, so here's QE, and that is 18 radical 2. That's one of the diagonals. And we're also told that SR is 18 radical 2. And we could have known that because a square is also a rectangle, And you know that rectangles, the diagonals are the same. So we knew that both diagonals would be the same. So in this case, 18 radical 2. Okay, so calculate the area of the square using the formula for the area of a parallelogram. Well, we did the formula for the area of a parallelogram on number 4, base times height. So if I want to find the area of this square that way, I can just do area is base times height. That means area is going to equal, now the base is 18 and the height is also 18. So base times height, 18 times 18. So that's 324. Okay, now let's calculate the area using the formula for the area of a rhombus. Okay, well we just did the formula for the area of a rhombus in number 5. For a rhombus, it's 1/2 diagonal times diagonal. Okay, and of course a square is a rhombus, with all 4 sides being the same. So it makes sense that I could use the formula for the area of a rhombus if I wanted to. Okay, so let's try that. So area is 1/2 diagonal times diagonal. So that means the area is going to equal 1/2 18 radical 2 times 18 radical 2. Guess what happens if you put that in your calculator? You're going to get 324 again. Which you should. You know, the area of a shape should be the same regardless of how you calculate it. Okay, but that's another way to calculate the area of a square. There's a third way to calculate the area of a square. Did anybody think of it? Well, writing base times height, 18 times 18, is a little bit redundant because for a square, the base and height are always going to be the same thing. Okay, so if I let S be the length of a side of a square, the area of a square is just the one side squared. So we don't really have to worry about a base and height. Just pick a side and square it. Alright, think about it. That would be 18 times 18, because 18 squared. And that would be the same thing as doing the base times the height. But just, you could think of it as doing a side squared. So if I do it that way, of course, that's going to be 18 squared. And 18 squared is 18 times 18. So you know that's going to once again give us 324. Okay, so that's 3 ways to think about finding the area of a square. Base times height, like a parallelogram. 1/2 diagonal times diagonal, because it's a rhombus. Or something special for a square. Just take a side and square it. Okay, last problem. Kite FOAD has these coordinates. So 0, -4. Let's go ahead and graph it. Alright, 0, -4 would be here. And then, so that's the point, that's F. 3, 4 would be here. Um, 8, 4 would be here. And 8, -1 would be here. Okay, so this is my kite. Okay, so here is our kite. Now we're supposed to find the area of this kite. Well, guess what? The formula for the area of a kite and the area of a rhombus are the same thing. Okay, so the area of a kite will be 1/2 diagonal times diagonal. Okay, so all we need to do is find the lengths of the diagonals. Alright, so diagonal 1, let's say, one of the diagonals will be OD. Alright, that's one of the diagonals. Okay, so that's one of my diagonals right there. So let's go ahead and calculate that. Okay, so OD, so focus on O and D. Those are the ordered pairs. So I'm just going to use the distance formula to find that diagonal. So that's going to be x minus x, so 3 minus 8 squared. Then y minus y, so 4 plus 1 squared, and then the square root of it all. So that turns out to be 5 radical 2. The other diagonal is going to be FA. Okay, so that's going to be my other diagonal. So let's go ahead and calculate that. So FA, again, I'm just going to use the distance formula, but this time focus on F and A. Okay, so x minus x, so 0 minus 8 squared, y minus y, so negative 4 minus 4 squared. And then, of course, the square root of all that. That's going to give us 8 radical 2. Okay, so if we go back and do the formula for the area is going to be then 1/2 5 radical 2 times 8 radical 2. Okay, so I just put that into the formula. So let's see what we get. That gives us 40. Okay, so the area of the kite is 40. Now, of course, to find the perimeter, we need to find the 4 distances. Now, I'm going to have to do the distance formula twice, but 2 of the distances I can just count. So let's get that out of the way first of all. OA, I can just count. So that's 1, 2, 3, 4, 5. Okay, OA is 5. Of course, AD, this is a kite, so those consecutive sides there are going to be the same. So guess what? AD is going to also equal 5. So we just need FO and FD. That's all we need. Okay, so FO, and again I'm just going to do the distance formula. So if you do the calculations using point F and point O, you get that length is radical 73. Again, I could save myself a little time. I need to know what FD is, but I really do not have to do the distance formula again. If this is a kite, then these consecutive sides here are going to be the same. So if FO is radical 73, then FD is going to be radical 73 as well. Alright, so the perimeter should just be the sum of all of these. Okay, it's going to be 5 plus radical 73 plus radical 73. Now, the best that that's going to give me without making a decimal is going to be 10, it's 5 plus 5, plus 2 radical 73. Alright, because there's 2 of them. So, without putting it as a decimal, this is the best it could be. But this could show up on a multiple choice question as a decimal, so let's find that as well. And that will be 27.1. And that's it. That's how you do the homework.